Good morning, everybody. I believe that we are live. And just looking here, just checking all of my system status here this morning. And it does indeed, I've got red lights, I've got stuff. This thing right here says live, so it must be. Let's go back here. Siri, set...
You're on 3208 40th Street, Metairie, Louisiana.
Thank you, dear. Thank you. Siri, set an alarm for 40 minutes.
The alarm's set for 8:47 a.m.
Thank you.
Your satisfaction is all the thanks I need.
Well then. Okay, so with that, what we're going to do here, my children, is that we are going to begin this first section here having to do with weight and balance. Okay, so that's what's happening here. And I'm looking here, somehow I have lost this connection. I'm still live. I'm going to ignore that. I'm going to look at this. Everything just looks fabulous. So that's where we're going. So, chapter 11, weight and balance. That's what we're after here today. So, we're going to go ahead and start here. Take a look in your hymnals here to chapter 11. And let's take a peek here. First of all, they talk about these things here, airframe limitations. As you might expect, you know, you can't have, like for instance in this illustration here, you have in figure 11-1, you have a Cirrus SR-22 pictured. My guess is you cannot put a grand piano in that airplane. Now, why would I say that? Well, physically, there's probably not enough room. But then again, when you think about this and you look at an airplane there that has 4 seats, remember the old adage is that you can fill the seats, you can fill the tanks, but you can seldom fill both. That has to do with smaller airplanes. Some of the bigger cargo transports, things like that, you can. Some of the larger single-engine airplanes, they say that you can basically carry whatever you can close the doors around. I, for one, am not all that anxious to test that theory, you know, on my airplane, but that's just what they say about the 206. So we do have some limitations. First of all, you have a weight element that you really cannot exceed. And there's a couple reasons for that. Number one is because you'll never get the airplane off the ground. Or if you did, it might take a runway 3 miles long for you to be able to do that. And that's just simply not practical. And then you have the balance element of things. And we kind of talked about that in the stability section when we looked at the stability of the longitudinal axis of the aircraft, primarily in pitch. The stability of the horizontal axis, you know, that roll or bank element of it. Our airplanes really aren't wide enough to really have too much of a, you know, an off-center load, with the exception of fuel. Remember that you have fuel that are in the fuel tanks. Those tanks are extended out there on the wings. You can have an imbalance out there with regard to fuel. And so it's like, for instance, in the Diamond, they say that you can have an 8-gallon per side differential and still have full control of the airplane. It's one of the reasons that we have a timer in the G1000 set up for this. You know, I'm getting a phone call here from the veterinarian. Stand by. Good morning, this is Greg.
Good morning, it's Dr. Lang. How are you?
Dr. Lang, how are you?
I'm doing fine, thanks. Our dog is doing fine too.
Oh, good, good. When is he going to be ready to be picked up?
When would you like to do?
Well, actually, right now, you won't believe this, but you're actually in one of my class videos right now. You are. I'm actually teaching, and you're on the phone here. Yes, I know. And so I'll be done here in about an hour and a half, and I could swing that way about 9:30 maybe?
9:45, is that what you said?
9:45 or 9:30, either one.
Let's shoot for 10. That way I can have everything all ready for you. Would that work for you?
10 o'clock, I'll see you then.
All right, we'll see you then.
Thanks, Dr. Lang.
You're welcome.
Bye. So, Sebastian, my lovely bride's 11-year-old golden retriever, has ACL surgery yesterday. So it's an ACL replacement, and had the surgery. Everything went well. He spent the night there, and so I'm going to go pick him up a little bit later. Yeah, so that was kind of what that was, and that's the reason that I took that call, is because I was kind of expecting it. So there you go. Welcome to live broadcasting. So remember the 8-gallon imbalance there that you're allowed in a Diamond DA40. We have a timer set up in the G1000 so that every 30 minutes you switch the tanks so that you're drawing from one side or the other. Even if you're at the max, at the max fuel burn of, let's say, 12 gallons an hour, half an hour is going to be 6 gallons, and so that keeps you within that 8-gallon range, you know, switching those tanks every 30 minutes. So we switch the tanks, and we fill the tanks, which is where we drink some water, and then we check the tanks. We use the pulse oximeter to make sure that we're getting the proper oxygenation as we fly. So there's that little bonus information. So that's what we're looking at. We're looking at weight and balance. So with this, let's look here at the weight factor. One of the things that we look at here is we have to look at not just the takeoff weight of the airplane, but let's say that you have to do something wacky like, I don't know, a 60-degree banked turn at max weight. Well, if you look at this and you think, okay, if you've got an airplane that weighs 3,000 pounds on a level turn at 60-degree bank angle, you're asking those wings to carry 6,000 pounds, fully double the amount of weight that you would ask those wings to lift on takeoff. So it's in some of the actual maneuvers where some of the stresses can be loaded on that airframe. If you look at this and you think about it, you think about, okay, is a heavier airplane, is that more desirable than a lighter airplane? Well, take a look at those bullet points there, just across from 11-2, is that you look at the consequences of flying with a heavy airplane, and look at all of those things. You've got a higher stall speed, meaning that the aircraft will stall at a higher airspeed. Higher takeoff speed, longer takeoff run, poor climb performance, lower cruise, lower cruising level, let alone the speed, less maneuverability. You're going to burn more fuel. You're not going to have as much speed. You've got a higher landing speed and landing distance, and it's going to be harder on your brakes. So I think we can all agree that the heavier the airplane, the greater the demand on all of the structural elements of that airplane, as well as some of the economics of that airplane as well. So these are some of the things. I'm not going to read all of these for you because, again, you can look at this. But one of the things here, remember that the margins here on page 289, is that some of these margins, the stuff that you see in italics, normally this is solid gold, and it says right here, guys, look, it says this: never fly an overloaded airplane. You see, right there, it says not to do that. And there's the reason why. So there it is. So now we've got to look at some of these definitions of certain things. We look here at empty weight, and I want you to write this down: basic empty weight. Basic empty weight, BEW. The basic empty weight of an airplane is a weight that is calculated for that individual aircraft, not the type, but for that individual airplane. When that airplane is certified and it goes through that first inspection and then subsequent inspections, you get a weight and balance calculation for that specific aircraft. And so you get a weight and balance certificate for that particular airplane. Remember AERO. The documents that you must have in that aircraft, remember: airworthiness, registration, operating manual, and weight and balance sheet for that particular airplane. In that, the AI or the A&P is going to calculate what the basic empty weight is for that airplane. That is going to be the starting spot for your calculations. You may get a thing from Cessna or Diamond, let's say, that they will say that the empty weight of that aircraft is going to be 1,782 pounds. Well, you may have some additional equipment that's installed in that airplane that makes that airplane weigh 1,800 pounds. Which, by the way, that's the basic empty weight of November 141 Hotel Lima, one of our DA-40s. So that's the basic empty weight. And that's where the calculations begin. And so when you look at this, you think about, okay, what is included in that basic empty weight? It's the airframe and the power plant. It's all those things that are installed in there, non-drainable fluids, the things that can't easily be removed. Like, for instance, you wouldn't want to drain the oil every time that you did a weight and balance calculation, would you? But it's those things that are normally in that airplane. Now, I will say this. There are aircraft that gather what we call kind of that parasite weight, and that is stuff that pilots put in an airplane. You know, you've got all these things, and pilots seem to stuff all those pockets and everything else. It's a good thing. You know, we talk about spring cleaning. It's great once a year. More importantly, kind of before you do the annual inspection on the airplane. It's great to go through that airplane and just get rid of the clutter. Get all that stuff out of there. Get it out. Remember, a lighter airplane is a happier airplane. And just get all that stuff out, because over time it just kind of collects stuff, you know. So you got to watch that. And so also when you look here, some of the things that basic empty weight does not include are the things that you can take, you can put in and take out of the airplane. For instance, yourself. Yeah, the pilot. What about passengers? What about bags? What about, you know, other things that you might be putting in that airplane? It's stuff that you put in and that you take out of the airplane. That is not included in the basic empty weight. So just keep that in mind. Then we look here at something called a gross weight. And so with that, you have something like is a max gross weight. You may have something that indicates that your max gross weight of an airplane may be 2,636 pounds. That may be the max gross weight that you can have in that airplane. But then you'll have something called max takeoff weight, MTOW. And you may have a max takeoff weight of 2,360 pounds. Well, you're thinking, okay, there's a 6-pound differential there. What the hey? Well, that 6-pound differential, how much does 100 low lead weigh? 6 pounds. So you might have a calculation where you can put up to 2,636 pounds in an airplane, and then you're going to burn a gallon of that fuel in your taxi and your run-up prior to takeoff. And so at takeoff, that would put you then at 2,630 pounds, which may be the max takeoff weight of that airplane. So you have the max gross weight, which is the maximum weight you can put on that airplane at any one time. And then you have the max takeoff weight, MTOW. And when you do that, that's where when you roll across that line to pull out onto the runway, you should not weigh more than that max takeoff weight. Then you're going to have something called a max landing weight. That max landing weight may be a couple hundred pounds lighter than that max takeoff weight. Well, what the heck do you do? Do you go up there? Do you burn off some fuel? Do you do whatever? Yep. That's what you need to do, is that you need to make sure that you know what your max gross weight is, you need to know what your max takeoff weight is, and you need to know what your max landing weight is, because those items are going to be huge. If you try to land an airplane over your max landing weight, it could be hard on your landing gear if you kind of drop in a landing, if you don't just kind of grease it onto the runway. So those are some things that you have to consider, not the least of which is this little silly thing we call inertia, which is where you're screaming down the pipe to land this airplane, and now all of a sudden you're coming in, you're hot, you're heavy, and now you got to really get on the binders, brakes, and try to stop that airplane. That can be kind of a thing. So you got to be aware of those. So those are some things that we have here. The weight of fuel and oil. These bullet points should be memorized. 1 gallon of avgas, 6 pounds. We don't really deal a whole lot in liters, but if you kind of think that a liter of fuel is about 1.5 pounds, that'll kind of get you about there with that. And then you also need to know, how much does oil weigh? Oil weighs 7.5 pounds. So if, like in the Diamond DA40, you have a maximum oil capacity of 8 quarts, you know that's 2 gallons. 2 times 7.5 is going to be 15. So you have to kind of know what that is. A gallon of water, for instance, I believe weighs 8.2 pounds, I think, if memory serves. So this is one of the questions that, that kind of comes up. Why is it that sometimes rivers burn or whatever? Well, it's because that oil or that petroleum is lighter, it's less dense, floats to the top of that water, and that can actually catch fire. So there's that. We look at some of the other weight limitations. Some of the other weight limitations may mean that you have a max 0 fuel weight. And what that means is that when you have a 0 fuel weight, there comes a time that in that calculation that above any certain weight in that airplane, for it to meet its weight and balance calculations, is that anything over that weight must be in fuel. So you have kind of a stabilized kind of a thing there. There's some of the structural elements about having fuel in the tanks, etc., with a certain amount of weight in the fuselage. We don't really see that a whole lot in the training aircraft, but in some of the more high performance in the passenger carrying aircraft, we do see that as one of the weight limitations, which again is referred to as a 0 fuel weight. We'll talk about that another time. So here's one of the things here on 11-1 is that we look at some of the things here, and this is what they're referring to as a loading table. And we look at this and we say, okay, here's your maximum takeoff weight. Here's your maximum landing weight. Here is your empty weight, or your basic empty weight. Here is your maximum fuel load that you can put in that. Let's say that your taxi allowance that you're going to burn 1 gallon. And by the way, you'll find that calculation in your POH or your AFM. Maximum number of passengers, that basically has to do with the number of seats that you have in your airplane. How much baggage, what are the weight limitations at your baggage compartments there? And then you have your maximum fuel gallons here in where that fuel can go if you have multiple fuel tanks in your plane. Remember that the Diamond DA40, you have 2 wings, so you can load fuel in 2 wings, but you also have 3 fuel tanks in each one of those wings. And they kind of fill by gravity, but the tanks indeed are separate. You don't have to fill them all separately, but they're interconnected in the wings. But that's kind of what you have. So, and this is one of the things here that I talked about before, that in small planes it's not possible to carry both full fuel and full passengers and baggage and stay within the max gross weight of the airplane. It's just, it would be great if they actually did that, but they don't. So again, with one of these things, what you do is that if you have 4 seats in your airplane and you want to take 4 people somewhere, you got to think, okay, how much fuel can I not take with me? You have to think, okay, what's going to be my fuel load, and probably make more stops along the way if that's what you're going to do. So that's just kind of part of it. The balance portion. So the balance portion, guys, this is that thing here when we talk about weight and balance. is we think about, we have a weight component to our calculations about what can the airplane actually carry, and also carry not just for takeoff and landing, but also the performance of the airplane without causing any structural issues. But we have to think about the balance. Where is that weight going? We will have a center of gravity somewhere in this airplane, and that center of gravity will have limits. There will be a range. So you'll have a range where that from this point to this point, you could have the weight of this aircraft between these points, and that can be sliding depending upon the actual weight of the airplane. And it can have a forward limit, it can have an aft limit, or kind of at the back. Fore means forward, aft means toward the back. And so you have limits in here. The reason that they have those limits is, again, as you think about the longitudinal stability of the aircraft from the spinner to the tail, you've got to have the ability to control the pitch of that airplane. The pitch is controlled by the elevator. At some point, you could actually exceed the elevator's ability to pitch the nose of that airplane either up or down, depending upon what it is that you need to do, whether it's takeoff, whether it's landing. It's one of those things. You guys have heard me say that one of the things about my particular airplane is that it's designed to carry stuff. And when it's not carrying stuff, it has a real forward CG component to that airplane. And pilots have to be careful when they're landing that airplane to make sure that they have enough speed such that when they're landing the airplane, they come down to the round out and the flare, that they have enough elevator authority to raise that nose to land the airplane on the main gear as opposed to bounce it on the nose. So that's what we call a pilot-induced oscillation, is when you bounce that airplane on the nose and then you try to salvage that landing. And it's one of the things that can drive the propeller into the runway, and then you're looking at an expensive day and a sheepish phone call to your insurance company. So that's kind of, what happens. So you have to make sure that you have enough primary control surface authority to move that airplane in all phases of flight. Takeoff and landing, of course, is one of those phases of flight. So we look at this and we talk about something here called a moment of force. And if those of you that are sitting there thinking moment as a unit of time, stop it. That's not what we're talking about. Moment here, as they describe here, the moment of a force is its turning effect. Now, if you think about what I just talked about here before, and I talked about the longitudinal stability of an aircraft, let's say that this is the nose, let's say that this is the tail. Here's your center of gravity. So here's the longitudinal axis of the airplane, and here you have a force kind of pushing down here, and it's that kind of that turning effect. You're turning about the fulcrum right here, or this pivot point. That's kind of what they're talking about. And you can see here, if you just kind of think about, your days on the playground and everybody running out there to the teeter-totter, and you can think about those kinds of things. Everybody, I think, has that kind of that childhood memory of the teeter-totters, and you think about this. Okay, so here's this teeter-totter. Here's the little fulcrum and here's this thing. Well, most teeter-totters are built so that they have, let's say, 10 feet this way, 10 feet that way. And the teeter-totter is relatively balanced. But you know that if you're a heavier person on one end and you have a light person on the other, it may be hard, if not impossible, to actually make that teeter-totter work and have any fun at all unless it's balanced. And then in the playground, you kind of figure that out. Okay, so here I am out there, weighing in here at a smooth 250. And then I know that I'm going to have 3 or 4 people probably at the other end of that teeter-totter, to kind of make that thing work. So, everybody kind of has that thing about, just sort of eyeballing balance. Sort of the same thing here, but there's a different way that we think about it. The other way to think about moment is the effect of a weight at a given distance from a certain point. The effect of a weight at a certain distance from a point. I think I did this in this class. I brought somebody up there and I took a backpack. And I slung a backpack right here on somebody's shoulder. Well, here's the weight of the backpack. The backpack may weigh 20 pounds. And then I put it right here. Well, you can hold that arm out there pretty easily there with that backpack right here, and let's call that the fulcrum point. But when I start sliding that strap a little bit further out, now it becomes a little bit more heavy. It feels more heavy. Have we added any weight to it? Nope. I haven't slipped a brick in it or anything else. You move it out a little bit further, now it feels even heavier. You move it out a little bit further, now it feels real heavy. It feels real heavy. It's the same weight, but it just feels heavy. So when you think about moment, you can think about moment as the effect of a weight at a given distance from whatever point you're talking about here, whether it's a fulcrum point, whether it's CG, whether it's something called a datum plane, D-A-T-U-M. We'll talk about that in a second. From here, and we think about that distance. Here, we think about that distance in inches here in the United States, along something called an arm, cleverly enough. So you have that weight that is measured along the certain arm of this equation. So that's kind of how we're going to think about things here with regards to the weight and balance of these equations. Good so far? Okay. So we look here and we know, again, just kind of some playground mathematics, that if we've got something way the heck out here, I've got to have something heavier over here. Or if I've got something here, I may have to have two somethings over there to kind of make all of that work. So this again, that weight, that balance portion, or that turning effect, that stability piece, if you will, about that longitudinal axis, it depends on that weight and it depends on that moment arm. Okay? So that's kind of how that works. Here you can look at this. And this is one of the things here is that we balance a loaded beam. We're going to come back to this here I think it's in part 2. To balance a beam, we need to provide a supporting force at its central position. So you need to balance this. You know that if you have a shorter arm over here as opposed to this arm, if this arm is longer and this arm is shorter, I'm going to have more weight on the shorter side than I will at the far end of the longer side, to kind of equal this weight here at this balance point, or this center of gravity. So that's kind of how that works. So here is something that we're going to talk about here. Here is an equation, and I think that I've used this before. I cannot remember. I have slept since I did this before, but this is something that I want you to write down. Weight times arm equals moment. Write that down. Weight times arm equals moment. Learn it, live it, love it. Okay? This is the basic formula for all of your weight and balance calculations. Weight times arm equals moment. The weight is going to be the raw weight of whatever it is that we're talking about. The arm is going to be represented in inches. So this is going to be here. This is going to be in pounds. This is going to be in inches. And moment is going to be expressed in pound inches. Okay? So that's how moment is going to be expressed. There's another way to write this equation. You can express this equation a little bit different. You can go with total moment divided by total weight equals arm, or CG. So that's another way that you can express that formula. Okay? So we're going to keep that in mind. Those are things, my children, you are going to want to write down and that you are going to want to memorize. weight times arm equals moment, and total moment divided by total weight equals the arm, or ultimately your CG. Okay, so write those down. Now then, we're going to talk about these things here. And what I want to show you now is this airplane datum. Now, you'll see here on this illustration here on figure 11-10, you have a datum. A datum is something that engineers they sort of put a line in the sand to say all of our calculations will begin here. It can begin here at the spinner. It can begin here somewhere in the engine compartment. It can begin here on the firewall, or like in Cirrus, it's somewhere out here in space, out here in front of the airplane. And I don't know, I don't really get that, why they do that, but that's kind of where it is. So we have to have a datum. Let's pretend that this datum that we're going to be is, let's say, here at the spinner. Now, I shall now draw. So this is something else that I want you guys to draw here. Okay, so here's your airplane. I am a very good drawer. Let's say that this is our datum plane. This is our datum plane. And when I say plane, it's P-L-A-N-E, not P-L-A-I-N. This is that point by which these calculations begin. Now then, so this is where we begin measuring. Now we are going to measure aft through the length of that airplane, and kind of using that longitudinal axis as our guide. Now remember what I said. Remember that I said that that arm, and we can kind of think of this as kind of the arm, is that it's going to be expressed in inches. So let's say right here we start here and we use the engine. Okay, so here's the engine at, let's call that 18 inches. That's 18. And these are just hypothetical here, guys. Let's say that we have two seats in this airplane. We've got front seats, we have back seats. So on the front seats right here, let's say that these front seats, which is going to be the pilot and front seat passenger, let's just say that that's at 30 inches. Let's say that that rear seat and rear seat passengers, that's at, let's call that 38. Well, I guess technically it'd be closer to 40 inches or something like that. Hang on here. Come on. Let's call this 40 inches. And again, we're just kind of, this is just sort of make them up kind of stuff. So we've got the front seat. We've got the rear seat. We need some fuel, don't we? So here's some fuel. So this is going to be our fuel. And let's call that at 36 inches. I have in the back here, I have a baggage compartment. I've got a baggage compartment. I may have one, I may have two, I may have three different baggage compartments in an airplane. And so let's say I've got this baggage compartment here. Let's call that at 58 inches. Back here, something like this. So what we do is that each one of these items that we're going to account for, we're going to put our accounting hats on here. Each one of these items that we're going to account for comes at a particular station. We refer to these as stations. And these stations are going to be X number of inches aft of datum. Okay? So engine, well, it might be oil, that's going to be here at 18. Front seat passengers, that might be here. That the front seat, that's a station. That may be at 30 inches on the arm. Fuel at 36. Rear seat passengers at 40. Baggage here at 58. These are going to be things that we have to account for, okay? And so that's kind of where they go. We kind of look at those somewhere along here in these elements where we can put stuff in an airplane, right? Okay, so that's kind of it. So that's kind of the basic principles of how we're thinking about loading this airplane in some way that we can account for the weight of the stuff that we're putting in. Now, here's a question that people have. They say, okay, well, how do you know exactly what it weighs? You weigh it. I know, nutty, but that's what we do. I have in my flight bag, I've got this handy little device that I can put a little strap on a bag. I can set the reset button on it. I can lift it, and then it shows me the weight of every single bag that I'm putting in that airplane. And I use that. Now, here's something. In my politically correct frame of mind here, so let's say that you're flying with your mom, okay? Mom, I need to know how much you weigh. Oh, I haven't weighed myself in years. Okay, Mom, hun, love you to death. I really need to know how much you weigh. Well, I think I weigh probably about 119. Mom, you haven't seen 119 since high school, okay? Mom, I need to know what you weigh. Guys, here's the reason. This is no time to guess. And you can't be politically correct here. Do you know why? Because the lives of everybody that you're sticking in that airplane depend on this answer. You really kind of need to know. And look, I'm not judgmental. I don't care. I just need to know, because I know that there is going to be a limit to the amount of weight that I can put in each one of these stations, and the amount of weight total that I can put in here, so I can make my fuel calculations on how much fuel I can carry for us to operate this aircraft safely. Now, I'm sure there are better ways to probably broach this subject with your flyers out there, but guys, you gotta know. And again, you can't guess. You know, it's like you got to think about that. Okay, well, is that, you know, is that a weight? Is that with all of your winter clothes on, with those boots and everything else? And oh, by the way, the bag that you're bringing on there right now probably weighs more than my flight bag. So you've got to know all of that stuff, because guys, when we look at some of these NTSB reports next semester, we're going to be looking at these things where all of a sudden the pilot was just shocked about how much overweight the pilot actually was, because again, not knowing what it is that's going into that airplane. You as pilot in command have to know. So it's something that, you know, can be kind of awkward to have these conversations, but you got to ask and you got to know. Okay, so there's that. Now, remember we talked about this with regard to stability, 11-11. We talked about where that CG is. So part of that has to do with where's your center of pressure, where's your center of lift, how does the airplane work. All of these things from a dynamic stability standpoint we have talked about, but we need to think about this here. These paragraphs here, this is going to be an issue. Can we turn this airplane about that horizontal axis? And when I say turn that airplane, I'm not talking about banking. I'm talking about the stability of your longitudinal axis somewhere around that center of gravity, and having that full elevator authority to be able to pitch that nose up and down as you need to. That's the big thing when it comes to small airplanes, is can you do that? So if you look here in this, and you'll see that there are penalties that you pay for having a weight forward of the forward CG limit or aft of the aft CG limit. Of all of those, they say that the worst one is a CG limit aft of the aft limit, because even if you get the airplane off the ground, you may not be able to recover from a stall should one occur. And that's kind of the biggest thing that we have to think about. So I am trying to determine here, guys, if my alarm here is working or not, and I'm not sure that it is, or if it has, maybe I missed it. I don't know. And maybe I'm not quite there yet. So I'm just going to try and just keep going here, and hopefully we're still on time. So here, when you look at this, this is one of the ways that mathematically we can look at kind of where the, kind of where the weights and balances stuff are. Oh, there's my alarm. Oh yeah, kind of got a little groove on right there. Okay, so guys, that's going to end part 1. Now I'm going to stop all of this stuff here, and I'm going to record part 2. Part 2 is when we're going to start getting into some of the calculations, and then we will get into how you can start solving these weight and balance calculation problems that you're going to have on your quizzes and the FAA knowledge exam. All right, so there's that, and we'll get back to you here in just a moment, I think. Okay, hang on, here we go. I'm stopping this now. No, I'm serious. I'm going to push a button right here. It's going to shut the whole thing off. It's just going to stop it cold, okay? So here we go. It's going to do that right now.